I have a question for you. What is this?
Ice.
And where does ice come from?
The refrigerator.
Well, kind of.
And the snow.
Well, snow is kind of icy, isn't it? Well, how do you make an ice cube?
And I know.
Does anybody know where's it come from? What's the start is, David?
When you put it in, when it melts, it turns into
What does it turn
Well, it starts out as water, and then you get the water really, really cold. You put it in the freezer, and when it gets frozen, the water turns into ice. And if you have a cube maker or an ice tray, it turns into an ice cube. And then what would happen if we left it out here all day?
It'll just go into hot, then it will go into water.
It would go back to water, wouldn't it? It would melt and go back to water. So it started out as water, and we got it so cold that it froze into an ice cube, and then when it warms up, it goes back to water. And that's a ice cube that comes from water. Now I have a different kind of ice that I'm going to talk to you about today with our science experiments. It's called dry ice, and it doesn't come from water. It comes from carbon dioxide gas. So I am going to show you a piece of dry ice here, and it is so cold that I can't even touch it with my hands. I have to touch it wearing gloves because it's so cold that I could actually get a freeze burn if I touched it. So I have to have my gloves on. Right in here is dry ice. I'm going to reach in here with my gloves and show you like that. Does it look different than an ice cube?
Yeah.
Yeah, it does, doesn't it?
It looks like snow.
Yeah, it does kind of look like snow, doesn't it?
And
So this, we're going to do some dry ice experiments, but you know where it comes from?
Yeah.
This comes from carbon dioxide gas. So let me tell you about carbon dioxide gas. Did you know in this room here, everywhere, is air or oxygen that we breathe? Every time we take a breath, we breathe in air. And we use all the good parts of the air to make our bodies healthy and to have strong muscles. And then we breathe out. Wait, Draven, hold your questions, please. And we breathe out, and we use the parts that we don't need. We breathe out, and that's carbon dioxide gas. So we breathe in air or oxygen. Everybody breathe in. We use the good parts, and then we breathe out carbon dioxide gas. Breathe in oxygen. Breathe out carbon dioxide gas. We do that every time we take a breath. Now I'm going to take a breath and I'm going to trap it inside this balloon. I'm going to breathe in oxygen and breathe out carbon dioxide gas. And I trapped it in here. Well, you know how they make this dry ice? They have a great big machine, and they take and they trap some carbon dioxide gas in the machine, and then they compress it. That means they squeeze it together and they push it together, and they get it colder and colder and colder and colder till it's 110 degrees below zero.
Wow.
That's colder than the North Pole, and it turns into dry ice. So that's where it comes from. So you know what? If we warm up this dry ice, it goes back to carbon dioxide gas, because it started as carbon dioxide gas, and then we got it so cold that it turned into dry ice, and if we warm it up, it goes back to carbon dioxide gas. Just like our ice cube started out as water, and then we got it frozen into an ice cube, and then when it warms up, it goes back to water. Well, our carbon dioxide gas goes back. Let's see if we can see my carbon dioxide gas when it comes out of the balloon. You look real closely and let's see if you can see it. Did you see it?
no.
No, it was invisible.
I
It was invisible. Do you see the air that we breathe all the time?
Yeah.
No, you can't see the air, can you? It's invisible. Now, I'm going to use this bowl of water right here. And I'm going to, if I took a straw and I breathed in air and breathed that carbon dioxide out through the straw, what would happen if I put the straw underwater and breathed out? What do you think would happen?
It'll blow bubbles.
Yeah, I think that may be right. Look at that. Did the bubble stay on the bottom? No, it comes up to the top because it's full of carbon dioxide gas. And then it goes back into the room. Did anybody see the carbon dioxide gas when the bubble broke? Did you see it go back into the room? Let's see.
You drank it.
No, I didn't drink it. I'm blowing out. I'm blowing. But you can't see it, can you? Now let's watch this. Let's watch if I put some dry ice in here. Now, who knows what this is made out of? This metal. That's right. It's made out of metal. This is made out of glass. This is made out of metal. This dry ice is so cold that when I put it on the metal, it's going to make the metal vibrate. Good morning, Nava. We're talking about dry ice. Okay, let's listen and see if it does. It's getting this metal so cold that it's making it vibrate. Okay, now I'm going to put it in here. Let's see what happens. Look at that. It's like I was blowing my bubbles, only we can see it this time. Why do you think we can see it? It's okay, Mary Jean. Do you know what this is? This is the vapor going back into the room, and because the dry ice is so cold and the air in our room is so warm, do you know that's why we can see it? Because that cold, dry ice vapor, this is called vapor. Does it look like smoke? But smoke comes from fire, and we don't have a fire there, do we? So it's not smoke. We call this carbon dioxide vapor. And did you see when it comes out? It goes down. It doesn't go up. It goes down because it's heavier than the air in the room.
Can we touch it?
No, and when we do our science experiment, everybody's going to stay right on their carpet squares. Can you do that for me, please?
She's safe.
Okay, now, let's just see here. I am going to put this over to the side here, and I am going to take this. This is made out of glass. It's a glass bottle, and I'm going to put some dry ice in it.
With the spoon. Watch it.
See these little dry ice? It's just, the spoon is getting so cold already that it is. Can I touch this? No, because dry ice is so cold, 110 degrees below zero, colder than the North Pole, that if you touched it, I would get a freeze burn and I'd have to go right to the hospital. So that's why I wear my gloves if I'm going to touch it. Otherwise, I put it in the spoon and I don't touch it. Okay, I'm going to put a little bit of water in here to help it vaporize. So can everybody say the word dry ice for me? Dry ice. And then can everybody say carbon dioxide vapor? Carbon dioxide vapor. Now look at this, I can actually pour it out. Look, it wants to come out, doesn't it? It wants to come out of my bottle. So you know what I'm going to do? I'm going to take my balloon and put it on top. What do you think will happen?
Nothing.
Well, let's just see.
It's gonna blow up.
It's not going to pop.
Look at it's blowing up. So what happens is the vapor wants to come out of the bottle, but the glass, it can't push the glass, can it? Because the glass is too strong. So it pushes against the rubber of the balloon, which is flexible and will expand. And now I'm going to take this and I am going to put some of this in it. Who knows what this is?
Oil.
Well, this is soap that you used to wash dishes with and things like that. So I'm going to put some soap in there. And then I'm going to take my jar. You see my special jar? And it has a tube coming out of it. See where the tube is connected right here? And it comes out. And I'm going to put some dry ice in that. I'm going to put a bunch of dry ice in there.
There's more dry ice.
Okay, now, oh, listen,
Like this, Peter.
making it so cold, that metal spoon, it's making it vibrate. Oh, look at that. Now we've got our dry ice warming up, and bubbles come up, and the carbon dioxide vapor goes back into the room, doesn't it? Is there any coming out of the end here? No, there's nothing coming out, but look, if I take a cap and I put it on top here, let's see what happens. It comes out of the end, doesn't it?
It's like a water hose. It's like a fire extinguisher.
Yeah, look at
Oh
that.
my
So if I
God.
take the cap on, I trap it, and it comes down this tube and comes out the end here. If I take it off, it comes out the top. So I'm going to put the cap on, and then I'm going to put it in the soap here, and I am going to see what happens. I'm going to put some gloves out here, and I'm going to put this glove on my hand.
Why?
I'm going to show you. Okay, ready? I'm going to put it in the soap.
Whoa. Oh, got it. Those are better bubbles. Good. Oh, wow. We need to make some of those in big.
That part's not.
Whoa, look at that. That's a big one. Look at that one. Now, I wonder what would happen if I blew a bubble and tried to put it in the water.
Look.
Oh,
Oh.
it bounced. Look at that.
It's like a posting. No, it's like a bubble maker. All that popping
Look at that. They're bouncing around on there.
and popping.
Some of them do. Oh, look at this one shrunk down and how teeny it is. Look at that.
That's the baby. Baby. Hey. Whoosh. Whoa.
Isn't that fun? Look at that. Now look at this. Watch this. I'm going to blow a bubble up. And watch if I open this up. Let's just see here. I'm going to blow a bubble. Oh, and if I watch it, oh look, it gets smaller. And if I close it up, it gets bigger again. And if I,
Can we touch those bubbles?
and then if I open this up, it shrinks back. And if I close it, it grows bigger.
Wow.
And if I open it up, it gets smaller.
That.
What is he doing?
She's doing,
These are science experiments. This is, sometimes when you do a science experiment, you don't know what the answer is, and you have to do the experiment to see what happens. And so, that's pretty fun to do that.
what are you going to do with the other bowl?
Now, oh look, that big piece of dry ice that was in there, it's all gone now. It all went back into the room. That carbon dioxide vapor went all back into the room. Isn't that interesting? Okay, now I wonder what would happen if I took this.
What is that?
That's a big tube, a beaker. And if I took this piece of dry ice here,
Mom. It's hard.
yeah, I'm gonna put it down in here. Oh, look at that. What do we see?
What do you see?
Carbon dioxide.
Yes, a lot of carbon dioxide vapor coming out. And when it comes out, it goes down because it's heavier than the air. Now, I wonder what would happen if I put a little bit of soap on the top there. Let's just see. I'm going to dribble some soap in there. Is anything happening?
No.
Well, let's just keep an eye on it. I wonder if it'll change anything. Look at that! All those soap bubbles!
Looks like a snake.
It looks like a worm.
Look at that! Isn't that fun?
It's like a falling.
Look, it just keeps coming out.
Wow.
I wonder if I scoop some up, I wonder what would be inside.
What do you think is inside?
Oh, look, it trapped all of the vapor inside. Look at that. All those bubbles have vapor inside of them.
They keep coming.
Isn't that fun?
No. Yeah.
He doesn't want to stop the bubbles.
Now, let's see here.
He has more stuff to show us.
Let's put another one. Back over in here. I'm going to move this over to the side a little bit. And I'll bring this one back out
It's
front.
getting bigger. It's getting bigger.
Now, what happens if we put soap in this one? See all the vapor coming out?
Yeah.
Look, it's kind of going across the floor, staying low across the floor. All right.
It's coming
Oh, look at our balloon. It blew itself up pretty good.
Bigger.
It's a lot bigger. Okay, let's see what happens to the vapor if we put some soap on the top of our water there.
Oh, bubbles.
Let's see if that changes anything.
Same thing.
Can you see?
Look! Bubbles!
Bubbles, look at, where's the vapor?
Where's the bacon?
Where'd the vapor go that was coming out? Where'd it go?
Gone.
Well, you know what? It's trapped inside of the bubbles. Watch. It's all trapped inside of these bubbles.
Bubble bubbles.
The bubbles made a layer of film of soap on top of the water. And then when the vapor tried to get out, it blew a bubble, kind of like when you blow bubbles at your house. And they got trapped inside. And if we pop them, the vapor will come out. The carbon dioxide vapor.
I'm looking in the water.
And look at this. It's still going.
The balloon's getting bigger.
It is getting bigger, isn't it?
Where?
Look at all that vapor
What is
inside of it.
getting bigger?
So, now, let me say that, do you know that this dry ice, you might see some of this when you go trick-or-treating on Halloween. Because maybe somebody's going to put some dry ice inside the pumpkin, and then the vapor is going to come out the ears and the nose and the eyes, and that would look kind of interesting, wouldn't it? Are you going to be afraid if you see that? No, because you know that's dry ice. Right? Now, what if somebody tried to trick you and they had a big container and they put some black food coloring in there and they said, ha ha ha, you want some witch's brew? Is there any such thing as witches? No. Is there any such thing as ghosts? No. That's just pretend for Halloween, isn't it?
Yeah, and this pretend decorations that are made
Yeah,
of the
that's right. There's no such thing. But they might try and trick you and say that there's some witch's brew there and all that vapor will be coming out and they want to try and scare you. But are you going to be scared? No, because you know it's what? Dry ice. This is wet ice. This ice cube, see it's melting here because it came from water and when it warms up it goes back to water. But our dry ice came from carbon dioxide gas, so when it warms up it goes back to carbon dioxide gas.
Ask Rich. He has a question.
Yes, Drake.
Put the ice in there, please.
Yeah, what do you think is going to happen?
Yeah. What's your hypothesis?
What do you think's gonna
I
happen?
think it's gonna get bigger.
That other
Well, you know what? If I put this in there, you're probably not going to be able to see it, but if you look underneath, let's just see what happens. Okay, I have my ice cube right here. Did it go to the bottom?
No, it floats.
Look, it's floating.
We can play sink and float. Which
You
is
can see it?
floating. Yes, on the side.
I cannot
side, you're right.
get to the bottom.
Plus, you're right.
It's
Oh, that's
towards
okay.
the rim.
So it's going to turn back to water.
It's getting, yeah, see,
It's going to turn back to water.
that was very interesting. Jordan, that's a good question.
Okay, now I'm going to put this back aside here, and I am going to.
Big worm.
Big worm.
I'm going to take some more dry ice. Now, what do you think would happen if I put some dry ice inside of this cup, and then I put a top on it? What do you think will happen? And that carbon dioxide vapor wants to get out of this cup. What do you think will happen? What do you think?
Nice top.
Yeah, I think it might. I think it's going to push and push and push until it pushes the top off. Let's see what happens. Let's just see. Good morning, Drew. We're doing dry ice experiments. Okay, now I'm going to take some water here. Oh, you know what? Let me ask you, if the top pops off of this, is it going to be scary? No. Is it going to be a surprise? Yeah, I'll be surprised because we don't know when it's going to pop off. So let's see what happens. Let's see what happens. Okay, now, see, we've got all the vapor in there. Look at that. The vapor wants to come out. Okay, so I'm going to put the top on, and let's see what will happen. Okay, let's look. It's going to be pushing against the top, and pushing, pushing. See it pushing up? Can you see it moving? It's pushing,
Look at it very carefully.
pushing, and pushing,
Carbon dioxide gas has
and
to
pushing, and
It's a surprise.
It's a surprise.
Isn't that fun? Did that scare anybody? Was it a surprise? Because we didn't know when the top was going to pop off. Well, let's do it again. In this time, you guys can count with me and we'll see how long it takes. Okay, so we've got all of our dry ice in there, and the carbon dioxide vapor wants to come out. See how it wants to come out? I can just pour it out even. Okay, it's going to want to do it. Now you count with me. I'm going to lead and you count with me. 1, 2, 3, 4, 5, 6. How many? 6. Isn't that fun? Okay, well let's do it one more time. And do you think it'll be faster than 6 or slower than 6? Okay, let's see. We'll make a prediction, and then we'll see what happens. Okay, Drew, count with me. 1, 2, 3, 4, 5, 6, 7. Okay, now I have another question. What would happen if I use this teeny little container and I put a top on it? What would happen then? Should we try it?
I don't know.
Let's try it.
We should try.
Okay. Now I'm going to have to get another piece of dry ice for this. Let's just see it. Okay.
Yes,
Okay, here it is. That spoon's so cold. Okay, I'm going to put that dry ice in there. And then I'm going to pour a little bit of water in there. Oh, look. See, the carbon dioxide vapor wants to come out of this. And I'm going to put a little bit more in here that's warmer. Okay, now, Look at it. It really wants to come out, doesn't it? What do you think? What's our prediction on what's going to happen to the...
I think it's gonna pop just like the top.
Okay. Let's just keep our eye on it. We'll see what happens when it pushes and pushes and pushes against the top. Okay, keep your eye on it. 3, 4. Let's count and see how long it takes. And now, we know the top's going to pop off, right? So are we going to be frightened by that? Or are we going to be surprised when it comes up? Yeah, we don't know when it's going to, we don't know how long it's going to take. Look at that big bowl. The bubbles are getting littler and littler. Okay, carbon dioxide vapor wants to come out. Okay, ready? 1, 2, 3, 4, 5, 6. Thank you. That's pretty fun. Okay, oh, look at our balloon.
Look at the balloon.
Look how big that carbon dioxide vapor blew this balloon up. Look at that. So, what would happen if I let all the carbon dioxide vapor go out of this? What do you think will happen to it? Will it go? Will it fly all around? Let's see what happens if I let go of the carbon dioxide vapor coming out. Okay, ready?
It's not trying to make a noise.
Here we go. Okay. Now, remember we make dry ice out of carbon dioxide gas. So I'm going to fill this up with carbon dioxide gas. Should I put in more carbon dioxide gas?
Yeah.
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 More carbon dioxide gas? More carbon dioxide gas?
Nothing's going to happen. Oh, more? Nothing's going to
More carbon dioxide gas? More carbon dioxide gas? Is that enough? Okay, that's enough. Now I'm going to let it go and we're going to see what happens. Now if I held it like this, all the carbon dioxide gas would come out this way and it would push the balloon that way. If I held it like this, all the carbon dioxide gas would come out this end and push the balloon that way. And if I hold it like this, it would start out going up and then it might go flying all around. Which way do you want me to do it? Straight up? Okay, ready? Let's count down from 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Last one. Okay, now, do you know what they use dry ice for? If you were going to send some ice cream to your grandma and she lived far away, like in New York City,
No.
then what would happen if you sent it in the mail, if you sent ice cream to New York City to your
It
grandma?
would melt.
It would melt, wouldn't it? You know what they do? They take dry ice and they have special trucks and they have special train cars and they have special airplane sections where you can put dry ice, you can pack it around the ice cream and it'll keep the ice cream cold so that if you want to send it to your grandpa and grandma up in New York City and you pack it in dry ice, it'll keep it cold all the way there. And when they get it, it'll be nice and cold. It'll be still frozen. So that's what they really use dry ice for. But at Halloween time, we like to use it for fun things and for dry ice science experiments and sometimes on Halloween. So if you see it on Halloween, you can go up and you can tell your mom, I know what that is. That's dry ice. That would be fun. Does anybody have any questions about dry ice or carbon dioxide gas or carbon dioxide vapor?
Well, I can tell you something.
Oh, yes, great.
Two things that can make us healthy and strong. Breath and vitamins.
And vitamins too, and eating good foods, good healthy foods. Yeah, that makes your body strong too. But we have to have good healthy air to breathe because we take a breath all the time. You don't even know when you're taking breaths, you just go. You just breathe in and out and we don't even think about it. Yeah. Anybody else have any questions about dry ice or carbon dioxide? True?
And the dry ice melted.
Say that again?
If the dry ice melted, those will stop and they're clear.
Well, and what happens, dry ice vaporizes, it goes back to carbon dioxide gas because it started as carbon dioxide gas and then it's frozen to 110 degrees below zero, and then when it warms up, it goes back to carbon dioxide gas. It vaporizes. Oh, look. Let's see right there. Some people put it inside of their pumpkins. Well, thank you for listening. You are a very good Yes, Mary Ellen.
What is in the bowl besides the liquid soap that you put in there?
You know what? I forgot to do one experiment. My goodness.
Good question, Mary Ellen.
Well, who would have known?
I have a whole other experiment here. Look at this. If I take some of this dry ice and I put it in there, and I take the rest of this dry ice and put it all in there. Now, what I'm going to do is, okay, I'm going to take this piece of cloth and it's soaking in our soap. And I'm going to draw it across here like this. And let's just see what happens. It popped. Let's try it again. It makes one big bubble.
It's not doing it.
He knows what to do.
It's making rainbows too.
Do you
See
see
it?
the
You see that big bubble there? It's pushing it up.
Do you see
And
that?
rainbows. It's a rainbow.
Are you seeing a reflection of a rainbow?
Oh, there it
Oh, look, it's
goes.
getting bigger.
Everybody on your
It's
side.
getting bigger. One big bubble.
Oh my goodness.
All the carbon dioxide vapor is underneath trying to get out. It's pushing it up. Look at that.
Did it pop?
It's getting smaller.
What do you think is going to happen when it pops? You think the vapor's going to come out?
Yeah.
Did you vapor come out?
Look how big it's getting. Wow. Look at that.
I think it's going to go all over the room.
You think it's going to get as big as the room?
Yeah, it's going to get like a giant. The bubbles are going to go
Wow.
everywhere.
Look how big it is now.
It's going to go out of the room.
Look at that.
When the past week is going to pass it. Or it's going to reach the sky.
Look at that. It just keeps getting bigger and bigger. Would you want to see how big it can get, or should I pop it? Should we pop it? It's getting awfully big. Look at all that. That's a lot of vapor inside there.
Let's go bigger when we go. Now.
Would be bigger, why it's now?
Yeah.
Could you pop
Look at
it?
this.
Yeah, why did
Should I pop it?
get really big?
Okay, I'm going to pop it. Now, what's our prediction? What do we think is going to happen? What's going to come out of there? Well, I'll bet that we see some of that carbon dioxide vapor come out of there. Like when we pop those other bubbles in the soap. Okay, ready? 1, 2, 3. Whoa, look at that.
I want to see it again.
Wasn't that fun? You want to make another bubble? Do we have time?
Yeah, we're fine.
You sure? Okay, let's see what will happen here.
Look, y'all, it's making one big bubble. It's rainbow. What colors do you see on the makeup? What colors do you see?
Can you see all the vapor that's
See the colors?
yeah. Isn't that
I
fun?
see pink and purple and blue. What other colors?
Green.
Green.
Pink and purple.
Do you see any yellow?
There's something bigger. Getting bigger.
Look at that. Here it comes. It's going to get up above the edge of the bowl.
But don't pop it. I want to
Really big.
But we're gonna
Really,
do
really
music.
big.
If he gets really big, we won't be able to do music.
Now, what's going to happen though is that the dry ice, there, you know how the dry ice ended up here, all it went back to vapor? All this is going to go back to vapor, and there won't be any more vapor to push it up to get bigger. So once that dry ice is done bubbling, see it's getting smaller and smaller. Those pieces are pretty tiny in there now, and so they don't have as much vapor pushing it up.
Are you gonna get some more?
There are a lot of good science experiments. Do you guys like science?
Yeah.
Isn't that fun?
You like science?
Hey, the bubbles and that went away.
They did. All the dry ice in there went all back to vapor, so there isn't any more.
Pop it.
No more dry ice in the bottom there. No more dry ice in the bottom
Don't
here.
pop it.
No more dry ice in here.
Would you pop it?
You want me to pop it?
No.
Yes.
Because I don't think it's going to get too much any bigger now.
And Louise says yes.
So we'll pop it, and then everybody can go play. That sound like a good idea? Okay, ready? 1, 2, 3.
No,
Oh, look at that one.
I said no.
Pretty fun. Look at that. Okay, well now you know all about dry ice, which comes from carbon dioxide.